The Airbus A350 XWB is a family of long-range, two-engined wide-body jet airliners developed by European aircraft manufacturer Airbus. The A350 is the first Airbus with both fuselage and wing structures made primarily of carbon fiber reinforced polymer. It can carry 250 to 350 passengers in a typical three-class seating layout, or maximum seating of 440 to 550 passengers, depending on variant. The A350 competes with Boeing's 787 Dreamliner and 777 series. The A350 was originally conceived in 2004 as a largely new design, but with a fuselage based on the A330. This was rejected by some prospective customers. In 2006, Airbus redesigned the aircraft and renamed it the A350 XWB. Airbus stated that it will be more fuel efficient and have per-seat operating costs up to 8% lower than the competing Boeing 787. The redesigned composite fuselage also provides higher cabin pressure and humidity, and lower maintenance costs. The launch customer for the A350 is Qatar Airways, which ordered 80 aircraft of all three variants. Development costs are projected to be $12 billion. The airliner is scheduled to enter airline service in 2014. As of December 2013, Airbus has received orders for 812 aircraft from 39 customers around the globe. The prototype A350 first flew on June 14, 2013 at Toulouse-Blagnac Airport, France. Development, early designs. Airbus initially rejected Boeing's claim that the Boeing 787 Dreamliner would be a serious threat to the Airbus A330, stating that the 787 was just a reaction to the A330, and that no response was needed. When airlines pushed Airbus to provide a competitor, Airbus initially proposed the A330-200 Lite, a simple derivative of the A330. Which would feature improved aerodynamics and engines similar to those on the 787. The company planned to announce this version at the 2004 Farnborough Air Show, but did not proceed. On September 16, 2004, then Airbus President and CEO Noel Fourgeard confirmed the consideration of a new project during a private meeting with prospective customers. Fourgeard did not give a project name, and he did not state whether it would be an entirely new design or a modification of an existing product. The airlines were not satisfied, and Airbus committed $4 billion to a new airliner design. The original version of the A350 superficially resembled the A330 due to its common fuselage cross-section and assembly. A new wing, engines and a horizontal stabilizer were to be coupled with new composite materials, and production methods applied to the fuselage to make the A350 an almost all-new aircraft. On December 10, 2004, the boards of EADS and BAE Systems, then the shareholders of Airbus, gave Airbus an authorization to offer, and formally named it the A350. On June 13, 2005 at the Paris Air Show, Middle Eastern carrier Qatar Airways announced that they had placed an order for 60 A350s. In September 2006 the airline signed a Memorandum of Understanding with General Electric to launch the Genx 1A72 for the aircraft. Emirates sought a more improved design and decided against ordering the initial version of the A350, then placed an order for A350 XWBs in 2007. It later cancelled the order in 2014, following a fleet requirement review. On October 6, 2005, full industrial launch of the program was announced with an estimated development cost of around $3.5 billion. This version of the A350 was planned to be a 250 to 300-seat twin-engine wide-body aircraft derived from the design of the existing A330. Under this plan, the A350 would have modified wings and new engines, while sharing the same fuselage cross-section as its predecessor. As a result of a controversial design, the fuselage was to consist primarily of Ali, rather than the carbon fiber reinforced polymer fuselage on the 787. It was to see entry in two versions, the A350-800 capable of flying 8,800 mi with typical passenger capacity of 253 and 3-class configuration, and the 300-seat A350-900 with 7,500 mi range. It was designed to be a direct competitor to the 787-9 and 777-200ER. Airbus faced almost immediate criticism on the A350 project from the heads of two of their largest customers, International Lease Finance Corporation and GE Capital Aviation Services. On March 28, 2006, in the presence of hundreds of top airline executives, ILFC President Stephen F. Udvar-Hazy lambasted Airbus' strategy in bringing to market what they saw as a Band-Aid reaction to the 787, a sentiment that was echoed by GECAS President Henry Heschman. Udvar-Hazy called on Airbus to bring a clean sheet design to the table, or risk losing most of the market to Boeing. Several days later, Chu Choon Seng, then CEO of Singapore Airlines, made a similar comment. Having gone through the trouble of designing a new wing, tail, cockpit, and adding advanced new materials, Airbus should have gone the whole hog and designed a new fuselage. At the time, SIA was reviewing bids for the 787 and A350. Airbus responded by stating they were considering improvements for the A350 to satisfy customer demands. At the same time, Airbus then CEO Gustav Humbert suggested that there would be no quick fixes. Our strategy isn't driven by the needs of the next one or two campaigns, but rather by a long-term view of the market and our ability to deliver on our promises. Redesign and launch. On July 14, 2006, during the Farnborough Air Show, Airbus announced that the redesigned aircraft would be called A350 XWB. There was some previous speculation that the revised aircraft would be called the Airbus A350 or A280, with Airbus going as far as accidentally publishing an advertisement referring to the model as the A280 on the Financial Times' website. Within 4 days, Airbus achieved a sale of the redesigned A350 when Singapore Airlines announced an agreement to order 20 A350 XWBs with options for another 20 A350 XWBs. CEO Chu Choon Seng said that it is heartening that Airbus has listened to customer airlines and has come up with a totally new design for the A350. The proposed new A350 was a new design also including a wider fuselage cross-section. The new A350 fuselage allows seating arrangements ranging from an 8-abreast low-density premium economy layout to a 10-abreast high-density seating configuration, allowing for a maximum seating capacity of 440 Euro 550 depending on variant. The A330 and previous iterations of the A350 would only be able to accommodate 8 passengers per row in normal configurations. The 787 can accommodate 8 or 9 passengers per row, while the 777 typically accommodates 9 passengers per row, with some airlines using a 10-abreast seating layout. The A350 cabin is 12.7 cm wider at the eye level of a seated passenger than the competing 787, and 28 cm narrower than the Boeing 777, its other competitor. All A350 passenger models will have a range of at least 8,000 mi. On December 1, 2006, the Airbus Board of Directors approved the industrial launch of the A350-800, a 900 and a 1000 variants. The delayed decision on formal launch was a result of delays of the Airbus A380 and discussions about how the development would be funded. EADS CEO Thomas Ender stated that the A350 program was not a certainty, citing EADS Airbus stretched resources. However, it was decided program costs are to be borne mainly from cash flow. First delivery for the A900 was scheduled for mid-2013, with the A800 and A1000 following on, respectively, 12 and 24 months later. At a December 4, 2006 press conference, a few new technical details of the A350 XWB design were revealed, but no new customers were identified. John Leahy indicated existing A350 contracts were under renegotiation due to increases in prices compared to the original A350s contracted. On January 4, 2007, Airbus announced that Pegasus Aviation Finance Company had placed the first firm order for the A350 XWB with an order for 2 aircraft. The change to the XWB design imposed a 2-year delay into the original timetable and almost doubled development costs from $5.3 billion to approximately $10 billion. the total development cost for the A350 was estimated at $15 billion by Reuters. The original mid-2013 delivery date of the A350 changed, as longer than anticipated development activities for the aircraft forced Airbus to delay the final assembly and first flight of the aircraft to the third quarter of 2012 and second quarter of 2013 respectively. As such, flight testing will be compressed from the original 15 months to a 12-month schedule. A350 program chief Didier Everett stressed that the delays only affect the A350-900 and that the A350-800 and A350-1000 schedules remain unchanged. Design phase. Airbus suggested Boeing's use of composite materials for the 787 fuselage was premature, and that the new A350 XWB will feature large carbon fiber panels for the main fuselage skin. After facing criticism for maintenance costs, Airbus confirmed in early September 2007 the adoption of composite fuselage frames for the aircraft structure. The composite frames will feature aluminium strips to ensure the electrical continuity of the fuselage. Airbus will use a full mock-up fuselage to develop the wiring, a different approach from the A380, on which the wiring was all done on computers. Airbus confirmed that it will further develop a full bleed air system on new airliners' turbofan engines, rather than the partial bleed configuration used on the Boeing 787. Rolls-Royce agreed with Airbus to supply a new variant of the Trent engine for the A350 XWB, named Trent XWB. After the low-speed wind tunnel test, Airbus froze the static thrust at sea level for all three proposed variants in the 330-420 kN range in 2010. General Electric has stated it will not offer the GP7000 engine on the aircraft, and that previous contracts for the ganks on the original A350 did not apply to the XWB. Engine alliance partner Pratt & Whitney seems to be at odds with GE on this, publicly stating that it is looking at an advanced derivative of the GP7000. In April 2007, Airbus former chief executive Louis Gallois held face-to-face talks with senior GE management over developing a new variant of the ganks engine for the A350 XWB. In June 2007, Airbus Chief Operating Officer John Lee indicated that the A350 XWB will not feature the ganks engine, saying that Airbus wants GE to offer a more efficient version for the new Airbus airliner. Since then, largest GE engines operators Emirates, US Airways, Hawaiian Airlines and ILFC have selected the Trent XWB for their A350 orders. In May 2009, GE said that if it reaches a deal with Airbus to offer the current 787 optimized ganks for the A350, it will only power the A800 and A900 variants. GE believes it can offer a product that outperforms the Trent 1000 and Trent XWB, but has been reluctant to support an airframe that competes directly with its GE 90-115B-powered 777 variants. In January 2008, French-based Thales Group won the $2.9 billion 20-year contract to supply avionics and navigation equipment for the A350 XWB. Thales competed against Honeywell and Rockwell Collins for the flight deck supply contract. US-based Rockwell Collins and Moog Incorporated were chosen to supply the horizontal stabilizer actuator and primary flight control actuation, respectively. The flight management system will include several new safety features. Regarding cabin ergonomics and entertainment, in 2006 Airbus had signed a firm contract with BMW for development of an interior concept for the original A350. On February 4, 2010, Airbus signed a contract with Panasonic Avionics Corporation to deliver in-flight entertainment and communication systems for the Airbus A350 XWB. Production and testing. The A350 XWB production program sees extensive international collaboration and investments in new facilities. According to Flight Global, Airbus constructed 10 new factories in Western Europe and the US, with extensions carried out on 3 further sites. Among the new buildings was a £570 a million composite facility in Broughton, Wales, which would be responsible for the wings. In June 2009, The National Assembly for Wales announced provision of a £28 a million grant to provide a training centre, production jobs and money toward the new production centre. Another new construction facility was the composite rudder plant in China, which was opened in early 2011. Airbus planned to introduce new techniques and procedures to cut assembly time in half. Airbus manufactured the first structural component in December 2009. Production of the first fuselage barrel began in late 2010 at its production plant in Illescas, Spain. Construction of the first A350-900 center wing box was set to start in August 2010. The flight test program of the Rolls-Royce Trent XWB began using the A380 development aircraft in early 2011, ahead of engine certification at the end of 2011. The first engine test on the Trent was made on June 14, 2010. The forward fuselage of the first A350 aircraft was delivered to the factory on December 29, 2011. Final assembly of the first A350 static test model was started on April 5, 2012. Final assembly of the first flight test A350 was completed in December 2012. The fifth and final test aircraft is expected to fly in June 2014. In June 2011, the A350-900 was scheduled to enter service in the first half of 2014, with the A800 to enter service in mid-2016, and the A1000 in 2017. In July 2012, Airbus delayed the A900's entry date by 3 months into the second half of 2014. On June 2, 2013, Airbus powered up the Rolls-Royce Trent XWB engines on the A350 aircraft for the first time. Airbus also confirmed that flight test program is to last 12 months and use 5 test aircraft. The A350's maiden flight took place on June 14, 2013 from the Toulouse-Blagnac Airport, near the company's aircraft delivery center. Airbus chief test pilot said, "It just seemed really happy in the air, and that all the things we were testing had no major issues at all." Launch customer Qatar Airways is to receive its first aircraft in the second half of 2014. On June 11, 2014, it was reported that Emirates cancelled an order for 70 A350s, an event that prompted an immediate, if small, drop to the stock prices of both Airbus and Rolls-Royce. Design. In September 2007, Airbus rolled out new design advances to a gathering of 100 representatives from existing and potential XWB customers. The A350 XWB will be built on the technologies developed for Airbus A380 and will have a similar cockpit and fly-by-wire systems layout. The A350 XWB will be made out of 53% composites, 19% alloy, 14% titanium, 6% steel and 8% miscellaneous. This compares to the Boeing 787 Dreamliner, which consists of 50% composites, 20% aluminium, 15% titanium, 10% steel and 5% other. October 2008 was the Airbus internal goal to freeze the design, and Airbus expects 10% lower airframe maintenance costs and 14% lower empty seat weight than competing aircraft. Airbus says that the new design provides a better cabin atmosphere with 20% humidity, a typical cabin altitude at or below 6,000 aft, and an airflow management system that adapts cabin airflow to passenger load with draft-free air circulation. Airbus is aiming to certify the A350 with 350-minute ETOPS capability on entry into service, and reach 420-min ETOPS capability later. Fuselage. The new XWB fuselage will have a constant width from door 1 to door 4, unlike previous Airbus aircraft, to provide maximum usable volume. The double-lobe fuselage cross-section will have a maximum outer diameter of 5.97 am, compared to 5.64 am for the A330 per A340. The cabin's internal diameter will be 5.61 am wide at armrest level compared with 5.49 am in the Boeing 787 and 5.87 am in the Boeing 777. It allows for an 8 abreast to a Euro 4 a Euro 2 arrangement in a premium economy layout, with the seats being 49.5 cm wide between 5 cm wide armrests. Airbus says that the seat width will be 1.3 cm greater than the 787 seat in the equivalent configuration. In the 9 abreast, 3 standard economy layout, the XWB's seat width will be 45 cm, which will be 1.78 cm wider than the equivalent seat layout for the 787. However, the current 777 and future derivatives have 1.27 cm greater seat width than the A350 in a 9 abreast configuration. The upcoming 777X in a 10 abreast configuration is to have a greater seat width of up to 45.72 cm due to its wider interior cabin. The 10 abreast seating on the A350 is similar to a 9 abreast configuration on the A330, with a seat width of 41.7 cm. Overall, Airbus promises passengers more headroom, larger overhead storage space and wider panoramic windows than current Airbus models. Wings. The A350 features new composite wings with a wingspan that is common to the 3 proposed variants. With an area of 443 am2, it will be the largest wing ever produced for a single-deck wide-body aircraft. The wingspan of 64.8 am is 4.5 am greater than that of the A330. This is the same span as that of the longer-range variants of the Boeing 777, which have slightly less area. The wingtip will not have Airbus traditional wingtip fences, but instead will curve upwards over the final 4.4 meters in a saber-like shape. The new wing will have a 31.9 degrees sweep angle, helping to increase typical cruise speed to Mach 0.85 and maximum operating speed to Mach 0.89. The A350-1000 have a wing design with about a 4% increase in surface area. A new trailing edge high lift system has been adopted with an advanced dropped hinge flap, which permits the gap between the trailing edge and the flap to be closed with the spoiler. The manufacturer has extensively used computational fluid dynamics and also carried out more than 4,000 hours of low and high-speed wind tunnel testing to refine the aerodynamic design, achieving the final configuration of wing and winglet on the Maturity Gate 5 on December 17, 2008. The wings are produced in the new £400 million /46,000 square meters North factory at Airbus Broughton, employing 650 workers, in a specialist facility constructed with £29 million of support from the Welsh Assembly Government. Nose. The XWB's nose section will adopt a configuration derived from the A380 with a forward-mounted nose gear bay and a 6-panel flight deck windscreen. This differs substantially from the 4-window arrangement in the original design. The new nose will improve aerodynamics and enable overhead crew rest areas to be installed further forward and eliminate any encroachment in the passenger cabin. The new windscreen has been revised to improve vision by reducing the width of the center post. The upper shell radius of the nose section has been increased. The nose is likely to be constructed from aluminium, but Airbus is currently running trade-off studies considering a one-piece carbon fiber structure. According to Gordon McConnell, A350 chief engineer, a carbon fiber structure would need titanium reinforcements for bird strike protection, thus the aluminium structure is the best cost-wise. Cockpit and avionics. The revised design of the cockpit dropped the A380-sized display and adopted 38 cm LCD screens. The new 6-screen configuration will have 2 central displays mounted one above the other and a single primary flight navigation display, with an adjacent onboard information system screen. Airbus says the new cockpit will allow advances in navigation technology to be placed on the displays in the future, plus flexibility and capacity to upload new software and to combine data from multiple sources and sensors for flight management and aircraft systems control. The A350 XWB will also feature a head-up display. The avionics will be a further development of the integrated modular avionics concept found on the A380. The A350's IMA will manage up to 40 functions such as undercarriage, fuel, pneumatics, cabin environmental systems, and fire detection. Airbus says benefits will include reduced maintenance and lower weight because IMA replaces multiple processors and LRUs with around 50% fewer standard computer modules known as line replaceable modules. The IMA runs on a 100 Mbps network based on the avionics full duplex standard, already employed in the A380 instead of the architecture used on the A330 per A340. Power plant. The Trent XWB family has two basic engines to power the three A350 variants. The baseline 370 kN thrust version for the A350-900 will be derated to 330 kN and 350 kN for the A800, while an upgraded 432 kN thrust version will power the A350-1000. The higher thrust version will have some modifications to the fan module. It will be the same diameter but will run slightly faster and have a new fan blade design and run at increased temperatures allowed by the new materials technologies from Rolls-Royce's research. The basic 248 TMTOW800 will be offered with a 330 kN sea level thrust rating, while the 279 TMTOW option will have 350 kN thrust. Airbus also plans to offer a hot and high rating option for Middle Eastern launching customers Qatar Airways, Emirates, and Etihad. This option has an increased thrust of 350 kN at higher altitudes and temperatures. The Trent XWB will feature a 300 cm fan diameter and the design will be based on the advanced developments of the Trent 900 and Trent 1000. The Trent XWB may also benefit from the next-generation reduced acoustic mode scattering engine duct system, which is a noise-dampening engine nacelle intake and a carry-on design of the Airbus's zero-splice intake liner developed for the A380. Engine thrust reversers and nacelles will be supplied by US-based Goodrich Corporation. The A350 XWB will feature a 1,268 kW Honeywell HGT 1700 auxiliary power unit, which has 10% greater power density than the previous generation of Honeywell's 331 APU family. Honeywell will also supply the air management system, the bleed air, environmental control, cabin pressure control and supplemental cooling systems. The ram air turbine will be supplied by Hamilton Sundstrand and will be located in the lower surface of the fuselage. The generator requirement for the ram air turbine is 100 kVA compared to 150 kVA for the A380. In light of the Boeing 787 Dreamliner battery problems, in February 2013 Airbus decided to revert from lithium-ion to the proven nickel-cadmium technology, although the flight test program will continue with the lithium-ion battery systems. Fuel and hydraulic systems. Parker Hannifin will supply the complete fuel package, inerting system, fuel measurement and management systems, mechanical equipment and fuel pumps. The fuel tank inerting system will feature air separation modules to generate nitrogen-enriched air that will be used to reduce the flammability of fuel vapor in the tanks. Parker will also provide hydraulic power generation and distribution system, reservoirs, manifolds, accumulators, thermal control, isolation, software and new engine and electric motor-driven pump designs. Parker estimates the contracts will generate more than $2 billion in revenues over the life of the program. Undercarriage. Airbus adopted a new philosophy for the attachment of the A350's main undercarriage as part of the switch to a composite wing structure. Each main undercarriage leg is attached to the rear wing spar forward and to a gear beam aft, which itself is attached to the wing and the fuselage. To help reduce the loads further into the wing, a double-side stay configuration has been adopted. This solution resembles the design of the Vickers VC-10. Airbus devised a three-pronged main undercarriage design philosophy encompassing both 4- and 6-wheel bogies to ensure it can keep the pavement loading within limits. The A350-800 and A350-900 will both have 4-wheel bogies, although the A800s will be slightly shorter to save weight. Both will fit in the same 4.1 am long bay. The proposed higher weight variant, the A350-1000 will use a 6-wheel bogie, with a 4.7 am undercarriage bay. French-based Messier Darty will provide the main undercarriage for the A800 and A900 variant, and UTC Aerospace Systems will supply the A1000 variant. The nose gear will be supplied by Liebherr Aerospace. Variants. There are 3 variants of the A350. and all were launched in 2006. In July 2012, the A350-900 is scheduled to enter service in the second half of 2014. Then the A800 in mid-2016, and A1000 in 2017. All variants are also to be offered as corporate jets by wholly owned subsidiary Airbus Executive and Private Aviation. A350-800. The A350-800 is to seat 270 passengers in a three-class configuration with a 9 abreast seating, and have a range of 15,400 km. It is designed to compete with the Boeing 787-9 and to directly replace the Airbus A330-200. In January 2010, Airbus announced that the A800 would be developed as a simple shrink of the A900, incorporating minor changes to the systems and structure, and share more hardware with the A900 rather than as an optimized variant as was previously planned. This increased commonality will allow a higher maximum takeoff weight, which will increase the range of the A350-800 compared to initial plans. The change will increase fuel burn by a few percent, according to the program's marketing head, Sophie Penderes. The A800's fuselage is 10 frames shorter than the A900 aircraft. The baseline 800 will be offered with an MTOW of 248 AT, MLW of 190 AT, MZFW of 178 AT, and 330 kN thrust engines. An optional 11-ton increase in MTOW to 259 AT with a corresponding increase of MZFW to 181 AT, MLW to 193 AT, and a higher thrust 370 kN engine was announced by Airbus in April 2010 to be made available for customers as an option. While the increased weights compensate for the increased empty weight of the aircraft and associated minor fuel burn penalty due to maintaining commonality with a 900, it also resulted in an increase in the aircraft maximum structural payload capability by 3 AT, or 459 km of additional range. As development continues, Airbus plans to decrease structural weight in the A800, which should be around airframe 20. In a bid to save on development and production costs, Airbus has recently encouraged those customers who have ordered the A800 variant to upgrade to the more popular A900. While many customers have changed their orders, a number are yet to be convinced of the benefits. A350-900. The A350-900 is the first A350 model and seats 314 passengers in a three-class cabin and 9 abreast layout. It has a standard design range target of 15,000 km. Airbus says that the A350-900 will have a decrease of 16% MWE per seat, a 30% decrease in block fuel per seat and 25% better cash operating cost than the Boeing 777-200ER. The A900 is designed to compete with the Boeing 777-200ER and replace the Airbus A340-300. The A900 variant has been proposed but not yet launched. It would feature the higher engine thrust, strength and structure and undercarriage of the A1000. Range of the A350-900 was estimated to 17,600 km, which would be boosted to about 19,100 km by these design improvements to compete with the Boeing 777-200LR and be capable of non-stop flight from London Heathrow to Auckland. The A900F freighter variant has also been proposed. Aviation Week reported in July 2013 that Airbus has been discussing with airlines a possible A900 regional version. This version would be for airlines that fly short to medium routes that do not need the extra range, maximum fuel capacity and weight of the baseline A350-900. Etihad Airways and Aer Lingus have firmly expressed their interest in the regional variant. A350-1000. The A350-1000 is an 11-frame stretch over the A900 and will enter service after the A800. It is the largest variant of the A350 family and is to seat 350 passengers in a three-class cabin and 9 abreast configuration. It will have a range of 15,600 km. It is designed to replace the Airbus A340-600 and compete with the Boeing 777-300ER. The A350-1000 will feature a slightly larger wing than the A800/900 models. A trailing edge extension increasing its area by 4%. This will extend the high lift devices and the ailerons, making the chord bigger by around 400 mm, optimizing flap lift performance as well as cruise performance. These and other engineering upgrades are necessary so that the A1000 model does not suffer a reduction in range. Orders and deliveries. Airbus A350 orders and deliveries, as of March 31, 2014. Specifications. Specifications are preliminary until design is finished. Sources: Airbus, Flight Global, see also. Competition between Airbus and Boeing, related development, Airbus A380, aircraft of comparable role, configuration and era, Airbus A330, Airbus A340, Boeing 777, Boeing 787 Dreamliner, related lists, list of civil aircraft, references. Gunston, Bill. Airbus, The Complete Story. Sparkford, Yeovil, Somerset, UK, Haynes Publishing. ISBN A978-1-84425-585-6. External links, A350 page on the Airbus site, Airbus A350 XWB site, Airbus A350 XWB, project details along with images.